friction force, those who are static friction, limiting friction, kinetic friction. Can you explain me all the three types of friction quickly?
Static force is when static friction is when the object is at rest. So that's in the figure, it is F
It is this 4 and 3.
is
The
equal to
self
3 and
at
F
rest.
is equal to 4n.
Static word means?
And then limiting friction is
Static means
when,
rest. So this is acting when the body is
yes,
at rest. Okay.
yeah.
Then limiting friction.
Limiting friction is when the body is at a point where it can move.
It is
It's
about
higher
to.
than yeah, it's about to move. So
It's
it
the
is higher
maximum
than
value of
static.
static friction because body is still at rest. Body has not moved. This is still at rest. Okay. So it's the highest value of the static friction. Okay. And limiting in kinetic.
When the body starts moving and it's usually lesser than the limiting friction,
Yes.
the
Very good.
value.
When the body is in movement. Okay. Kinetic means movement. Very good. So these were the three kinds and we talked about them and we did the graph. Till here we stopped. Now coming to the cause of friction. So when we're talking about the causes of friction, it's basically the irregularities that are present. When we're talking about the cause of friction, see, let's say when you expand a surface, if you have two surfaces in contact to each other, and you're expanding those surfaces, like you're just expanding and seeing what is there at the micro level, you're observing it. So like this, let's say there is one surface. This is the edge of one surface, like this. Then you have another surface. This is how two surfaces are interlocked. Any two surfaces, even if I'm holding this pen, that is also two surfaces are coming in contact. The laptop is kept on the table, right? All these things, everything is in contact to each other. So whatever are the irregularities, because see, unless you have a smooth surface, in smooth surfaces we don't have friction, we have lesser of the friction force. So what happens, basically these areas that get knocked up here, these areas, this leads to rubbing, because if the irregularities are fit in, then the surface is just smooth. When surface is smooth, the interlocking is very less. They just glide over each other. Okay, just the objects are gliding over each other. So when you have these small interlockings present here, okay, here at this point, then at this point, then at this point, then at this point, like this, when you have all the interlockings present. When the bodies are in movement, so let's say this body is moving. Okay, this body is moving with some velocity v on this side. So this body is moving here. It is leaving this body past behind it. The above is moving. It's like two objects. They are gliding over another like this. So this is moving on the lower one. So if this is the case, then what happens? This rubbing causes the force of friction. So it's basically intermolecular force. This is what? This is the intermolecular force. Okay, between two surfaces, this causes the friction. So when two objects are rubbed against each other, the interlocking between the irregularities. Okay, this is because of the irregularities present. And where are the irregularities less? In the smooth surfaces. So for smooth surfaces, you have less of the friction force present. You have a very smooth tile. Kit of in the flooring is made up of very smooth, shiny tiles. You will tend to skid over it because there is no friction force to give you a strong grip. And you try walking on roads with irregularities, you'll have a better grip because friction will be there. Or the shoes that we wear, if you wear the footwears having a very smooth end, you will tend to slip often from those. And if you have those which have irregularities for holding the foot arch, then you are able to get a lot of grip because of the friction force present. Because the cause lies in the irregularities of the friction force. Okay, now there are two laws of friction on which the entire theory of friction is depending. First is friction depends on the normal reaction. This is very important, and that is the entire formula for friction. The entire formula for the friction force is that the friction force is directly proportional to the normal reaction. Let me show you it through a figure. Let's say this is a box, this is kept and it has a mass n. Here the normal reaction is n, downwards is mg. So the law says that the friction force, the value of this friction force will be depending on the normal reaction. This is what, this is the force of friction, while this is the normal reaction. Now, if your normal reaction is equal to something in certain case, then you can equate. Like in this case, if the body is at rest, let's say the acceleration is 0, body is at rest. So we can say N is equal to mg in this case. So our friction force will be depending on mg. But that is not necessary. Do we every time will have normal reaction balancing mg? That's not fixed. So you have to remember frictional force depends on the normal reaction. And there are questions which will confuse you. You will think normal reaction is equal to mg. Many students learn the formula of friction force as mu mg. No, in most of the cases, the normal reaction balances the mg. In most of the cases, you will find it by yourself. But it's not necessary. If I have the body kept in a different position where the gravitation force is acting downwards, but the contact force is acting in a different angle, then your normal reaction won't be balancing the mg, means the weight. So don't ever remember that. Okay, you use your logic, whatever you've studied. Okay, and then you go further for it. For if your normal reaction is balancing, let's say tension, so friction force will be balancing tension. It's not about the mg. Okay. Second is it's independent of area of contact. See, even if, because see, when we talked about the cause of friction, these inter irregularities present here, this part, these irregularities from both the surfaces. Even if they are coming in contact, it depends on the contact. Okay, it should be in contact. Once the body is in contact, friction force will be exist. This friction force will come. So it doesn't depend if you take a very big box or you take a very small box. It is independent of the area of contact. And definitely it increases with roughness. More irregularities, more contact, right? And more will be the force of friction. Okay. Coming to the formula and all, first you write this, the cause of friction. Okay. Write it here. Look, Neha, coming to the limiting friction and basically how you apply the formula here. Limiting or static, I'll start with the limiting first. See, you have the normal reaction, let's say, and downwards you have mg. So friction force is directly proportional to normal reaction. This is the law of friction. Laws of friction come in the exam. Some of the theoretical questions come. The benefits of friction, the disadvantages of friction force, that I'll write it. So we'll discuss it in the next class. That will give you a writing part. Now see here, when you replace the proportionality sign, there is a constant which is mu that comes. See, this is what F is the force of friction. This is the force of friction. While mu is the coefficient of friction. This is the coefficient of friction. And N is the normal reaction. N is the normal reaction. Okay, so F is equal to mu, N is the formula. Now, look, F is equal to mu N. For different kinds of friction, the values of this mu is different. Like if I'm talking about the limiting friction, for the static friction, the value of this mu will be some mu s. That will be the coefficient. This will be the coefficient of static friction. Okay, this is the coefficient of static friction. It will have its value when the static friction force is it. Then you have limiting friction. Here you will use mu L. These values will be given. You don't have to remember any value. Sometimes you'll need to calculate these values. So using the formula, you will be able to do. Okay, the very basic, easy questions we'll do today. So at least have a good practice of them, and then we'll practice more. And regarding your assignments, I've checked and shared with you. You already must be having. Have you seen? Have you gone through them? Did you see?
No, ma'am, I have to see them.
Okay. See, because today Simba won't be joining, so maybe tomorrow she'll join. So tomorrow I'll discuss. There are just a few doubts you have. I know you have marked a star in them. Apart from it, one question had you were doing everything correctly. The first question, I think, or where the table and a mass was kept. Just a small calculation error of writing 15 plus 5 as 10, and the entire answer went wrong. But concept part was right. So whatever questions you have done, apart from that small calculation mistake that changed your answer and you got it wrong. But apart from that calculation mistake, the concepts are right, Neha. I think you're able to understand the whole conceptual part. Did you have the test? No, it's on Saturday.
I did it yesterday.
You have given it. You've done it.
Yeah, yeah.
Okay. So how did you find it?
2 questions I had a doubt.
Two questions.
Two. One of them was
Uh,
a homework question which I had a doubt in also.
yes,
That same
yes. The
homework
assignment you
question.
have marked the stars on them. No. Yes, yes. I
The same
remember.
thing came for the consistency. I
Yeah,
couldn't.
yeah, same question as come. Okay, yes, we had the class. If we had the class before, we would have. Okay, so same homework question. Which question was it, Neha?
17th question.
No, just
A, it was A, B, C, a box moved without a thread, I think. There was no thread connecting them.
acha.
It was
Okay,
moved with a
yes.
force.
Okay,
Yeah,
okay.
that
All right,
was.
so no problem. I'll discuss it because same doubts are with Simra also. So I'll discuss it together because this is a very important topic. Friction force will come and it will just be an add-on. It won't be like a separate topic. You'll because friction force will be existing wherever your body was moving. You just add a friction force behind it. The way you've added weight downwards, friction force will be acting in the opposite direction to the movement. So friction force will be just an add-on. Have a very good practice of these concepts. I'll discuss it. Is there any weekly test paper which is left to be discussed? I think one paper is still left, no? Vectors
No, I
complete.
think we discussed the
Motion
last
in a
one.
plane have we discussed? No.
I think
That one
we
is
have.
there. Yes. Vectors we did discuss. After it, you had the test of the motion in a plane complete chapters, where one question was there, I cap plus J cap. Last
Oh yeah,
question.
yeah, we did.
One of the,
Got it.
yeah, that question was from your NCRT. I have to discuss that. I'll discuss the paper first tomorrow. Okay, and the assignments. Okay, so this is limiting friction. So this is the coefficient of limiting friction. So likewise, you will have the coefficient of the kinetic friction. When we are talking, I've written all these three things together. We'll do everything separately. I'll rewrite them. But at least this should be clear to you. Mu K, mu L, mu S, these things are given to specify. If you just have mu symbol, it means that this is not telling you to classify friction, just calculate the friction force regardless of their type. So but these mu S, mu L, and mu K will be given because you will be given questions where all the friction forces will be acting. Okay, so for that you should know the symbol. Like a very easy question, let's start with. Let me discuss this one. See, there's a body. The coefficient of static friction is given as mu S this. Okay, we have to calculate friction. Calculate friction. So look, we need to draw the FBD anyways. Okay, so this is, since this is the body, I'm drawing it here. It is in contact. So upwards, I'll have the normal reaction. Downwards, I'll have the weight. You have to draw the FBD first, regardless of you have the friction force question, you have any question, because you don't know which force is coming and is cancelling out with something. So draw all the forces and see what are you getting at the end. Now see, this is all that we have here in this. Now, one friction force will be acting. So friction force will be equal to mu S into N. Now, normal reaction is equal to mg. So we can say F is equal to mu S mg. Many students just remember this formula, mu mg, because most of the time normal reaction balances mg. But be careful, it won't be balancing always when you have incline problem. One question was there based on inclination. Remember in your assignment, like this. Yeah. So that one also we'll discuss. So in inclined planes I'll take as a separate segment. Means after friction only, because inclined plane problems come. After friction I'll discuss, because the questions are wasted if you are just doing it without friction. So after friction we'll do. So this is 0.3 into 10 into 10, that is 30 Newton. So 30 Newton of friction force is acting. So like this, you have to see what your normal reaction is equal to. If normal reaction is given directly, you write it. Okay, write it till here, then we'll have a discussion. Look, this says a body of 20 gram is placed on a rough surface having coefficient of static friction as 0.3. Calculate the force of maximum static friction. So body is there with a mass of 20 gram. Upwards is the normal reaction, downwards is mg because this is resting on a rough surface. So here we have to calculate force of static friction, which is mu s into N. So similar question, N is equal to mg. So F will be equal to mu s mg, which will be 0.3 into, now mass is 20 grams, 20 into 10 to the power minus 3 into 10, right? So that makes it, this is 6 into 10 to the power minus 2 Newton, which is 0.06 Newton. Right? This is the answer. Okay. We'll move to kinetic friction. You write down this. First, I'll just give you a very overview brief of all the friction forces. We'll go to angle of repose and all. At the end, we'll do good combination of questions because the questions come in combination. Okay. Okay, see, for kinetic friction, same thing. It means the body has started to move. Okay, let's say there's a vehicle. See, it will be there on a smooth, on a rough surface only, but this body will be moving with a certain velocity. And here you will have the friction force here. This is how you'll have the friction force at the backside. Now the rest of the forces will be existing. Here you will have the normal reaction. Here you will have mg. So friction force is directly proportional to normal reaction. The constant that comes is mu k into n. F is the frictional force. Mu k is the coefficient of friction, while n is the, again, normal reaction. Okay, let's look at an example. There's a car, okay, whose mass is 5 kg and it is moving with a velocity of 20 meter per second, mu k is 0.4. Now see this movement of 20 meter per second, if I draw the FPD of this car, the mass is given as 5 kg, which is completely not possible. This is definitely not a car. So see, the body is in movement here. So if I draw the FVD, I'll get normal reaction here, I'll get mg here, and I'll get the friction force here. But again, this is nothing to do with it until another force acts. Even if the body is moving here, it doesn't count. So here also we'll use the same formula, mu k into n, and our n is equal to mg. So here also we are going to use F is equal to mu k mg. So force of friction will be 0.4 into 5 into 10. That is equal to 20 Newton. Okay, this question you are going to tell me. All right, you write down this. Is it clear till here, Neha? It is easy right now, I hope.
Yes, ma'am.
Yes, Neha. What is your answer?
4.
4. Friction force is coming 4.
Yeah.
This will be. See, the body has a tendency to move downwards. This is put like this. If I have something like this is the wall. If I have something like this and I leave it, it will have a tendency to move downwards, right? If I'll be holding, it will be like this. As soon as I'll remove, this will have a tendency to move downwards, right? If the body has the tendency to move downwards, means it will move downwards. So the friction force, the force of friction, this acts upwards. Okay. And the normal reaction, and here mg will be acting, and this is 20 Newton inwards, and this is the normal reaction. Okay. So the normal reaction is equal to 20. Here the normal reaction is equal to 20 Newton. And friction force is mu s into n. Yeah, right. It will come. You've done it in the same way?
Yes, ma'am.
All right. Okay, correct then. All right, Neha, at least write down the question so that we can discuss this. Okay, Neha, let's discuss. It says a body of 10 kg is placed on a rough surface having coefficient of kinetic friction as 0.2 and static friction as 0.3. Okay, kinetic is 0.2, static is 0.3, kinetic is 0.2. Kinetic is 0.2. Then it says, what's the mass of the body? 10 kg. The body has the mass of 10 kg. It is placed on a rough surface having these coefficient of frictions. It says calculate force of maximum static and kinetic friction. That we'll do using the formula. See, force of static friction will be mu s into n. Now look here also when we draw the FBD of this figure. This is 10 kg. This is the normal reaction. This downwards has mg. So n will be equal to mg. So Fs will be equal to mu s into mg. Mu s is equal to, yeah, one more thing. Yeah, like look, in this question which we did, here our normal reaction was not equal to mg. It was balancing this 20 Newton, right? So be careful with that. Here it is. So it is 0.3 into 10 into 10, that is 30 Newton. 30 Newton is the static force of friction. Same thing for kinetic, we'll have mu k into n, फिर Fk will be equal to mu k into mg. And we can say the kinetic friction force mu k is 0.2 into 10 into 10. So this is equal to 20 Newton. So these are the two values of the forces we have, friction, static and kinetic. Is this clear?
Yes, ma'am.
Look, second part says if applied force is 10 Newton, you have to calculate the static friction. Means see, it says, if this is in the second part, it says, let's say this is the body of mass 10 kg. The FBD turns out to be that here we'll have the normal reaction, downwards we'll have mg, and the applied force is equal to 10 Newton. On the back side, we'll have the static friction force. Now see, here you don't have to use anything mu n, mu s or anything. Look, when it is static friction means the body is not moving, right? This means that body is not moving. Because why? Because see, in this question, it was kinetic friction. Okay, it was here also static friction. No, this is kinetic, sorry. Uh, no, this is static friction, yes. Look, here we have, it is asking us to calculate the static friction. Look, when compare it with this question, because it's a different question where normal reaction is not balancing the mg. It is saying static friction. So static friction means the body isn't moving, right? So we use this, that normal reaction is being balanced by 20 Newton, and we just got and put it into the formula. Now look, in this question, the body isn't moving. Means friction for static friction is a self-adjusting friction, right? So as we know, the static friction is a self-adjusting friction. Self-adjusting friction. So Fs will be balancing this F until it's moving, right? This will be, so this will be balancing, which is equal to 10 Newton. Okay. Now this say till here, see why is this answer and is this answer different? Both are static friction. Reason is that here the body isn't moving. There is no applied force. So normal and mg are moving, right? Whenever you have the applied force will act. Like look here, their applied force was acting 20 Newton. If this 20 Newton wasn't given to you, then your friction force would have been balancing this mg. You take the applied force into consideration. Look, here also we will be taking the applied force into consideration. 10 Newton has been applied, so static friction will try to adjust 10 Newton. Otherwise, this would have been this 30 Newton. This is telling you this is the maximum value. 30 Newton can be acted. Then it says third part, if applied force is 50 Newton, decide whether body will accelerate or not, and we have to calculate the acceleration also. Look, static friction, this is 30 Newton. Kinetic friction is 20 Newton. So it says if applied force is now 50 Newton. So look, third says, pay attention here, Neha, this part is important. This is a body of 10 kg mass. Now let's draw the FPD first. Here the normal reaction will be acting downwards, mg will be acting, and the applied force is 50 Newton here. And on the back side, you will have the static friction force. Now it says whether the body will move or not. Look, we have already calculated the value of the static friction. We know that the static friction cannot be more than 30 Newton. From part 1, from here we know it cannot be more than 30 Newton. So this will be, it's more or less like limiting friction. This value of 30 Newton is like limiting friction. So static friction is 30 Newton. Limiting friction and static friction don't have much difference. The last value of the static friction is the limiting. So this is the maximum value. It means whatever adjustment, if it is less than 30, like here, this was 10, it would adjust to 10. 15, it would adjust to 15. 20, it would adjust to 20. 25, it will adjust to 25. But 30 Newton, it can maximum give you 30 Newton. Even if it's 30.1 Newton, friction force will lose its capacity because it cannot balance. If something has a maximum capacity of 30 Newton, how can it balance the force of 50? Right, so on the backward side you will have the friction force acting of 30 Newton. Here you will have the force of 30 Newton acting, but it is saying decide whether body will accelerate or not. So we know since the friction force is lesser than the applied force, right? Friction force is lesser than the applied force, the body will accelerate. And in which direction, Neha, from this figure, left or right?
Right.
Right, because this is more, right? And we have to calculate the acceleration that we've already studied. Acceleration, how do we calculate? Two forces are acting like this. You have done this. How can you tell me how should we calculate the acceleration? FBD has been drawn. Now think acceleration. How do we calculate? What's the formula? Newton's second law says
Oh, equal and opposite reaction. So
no, that is
acceleration.
third law. Second law. First law was the inertia one. That external force will change the inertia. Third one was the action reaction. What was the second law? F is equal to ma.
Oh yeah.
F net is equal to ma. Now this is acting here. You've done multiple questions. How are you stucking at this question? This is 15 Newton acting towards right, 30 Newton acting towards left. Body will definitely accelerate in this direction. This force will be taken positive. So 50 minus 30 is equal to 10 into a. This is equal to 20 is equal to 10a. Acceleration is equal to 2 meter per second. Do you get it?
Yeah, I understood, but I forgot the law.
Yeah.
I know that
Revise
part
it.
with the law.
Okay. Revise the laws because they can be confusing and laws come to write as it is in the exam as well. So you've understood the entire question?
Yeah.
All right. Please write it now.